Hi everyone, it's a big pleasure to be join this meeting. I'm Professor Thiago Livoto from the Federal University of Santa Catarina in south of Brazil. So first I'd like to thank Lachazar Field for the invitation and to talk about plimanshiny today and how this web application can be used to extract vegetation index for agriculture experiments like plant breeding trials. The first thing you need is to install two R packages, and here are the orientations for installing the pliman R package, that is the backend of plimanshiny. You can also use plimanshiny as a web interface to make the workflow more easy and with no need to code. Yeah. After you install pliman, you need to do the same thing to install plimanshiny, and when you finish, you'll be able to open plimanshiny just by loading the library and calling this command run app. If all is going well, you find this screen that is running in your local host. This is the main interface of the package, and so in the today's example, I will show you how we can use plimanshiny to import an earth mosaic, build a shapefile, compute vegetation indexes, and extract these indices at a plot level. So first, you need to import your orthomosaic, and in this example, I will show you an orthomosaic from a barley trial that was kindly provided by these authors. So this is the main reference for the orthomosaics, and now you just need to locate the file, click here and select, and you'll be able to import the orthomosaic. Right. An important thing you need to do is to define the layers in your orthomosaic. So this example has 5 layers, including near, hedge agent, and the RGB bands, right? So you need to do in this setting and to inform the order of those layers. This is 3, 4, 5, 1, 2. I just click done, and this base map will be updated with the correct order of the layers. In a few moments you see the true color. You can also adjust this stretching for make the image more bright. And the next step is creating a shapefile that can be used for extract vegetation index for each of these plots. So this is a Barley trial, and this step can be made in this another menu. Yeah, using this tool, draw polygon, and you need to set or to define the 4 corner points that define your area of interest. Yeah, so just you can zoom in, zoom out here. This is my area of interest, and in these fields you can set, for example, the number of columns, in this case 4 columns, and the number of rows, and in this case is 25. You can also define the plot width, plot height, but just for now I click in create or update, and you will be able to see the generated plots in this tab here. You can see that we have now the plots, so you can come back to these control points, use this tool, edit layers, and make an adjustment to better define your region or interest. Yeah. Then just click it and update, and the plots will be updated based on those changes. If you need to see, for example, this plot or this plot, dimensions or measurements, yeah, you can click here in plot info. There are 100 plots, the total covered area, and these are important measures. Here you have 10.75 meters and 1.76 meters high. Yeah. And based on these values, you can define an useful area. For example, just let me uncheck this, to draw a polygon or a rectangular grid to extract the vegetation index in the useful area of these plots. For example, creating a buffer around the plot to avoid plot confusing with another. I will define for here 6 meters and here 1.2 meters. Just click update, and now you can see the plot size is updated now. For this example, I will just click shapefile build. This will finish the shapefile that can now be downloaded. And simple click here. I will put this in my download folder. And this shapefile can be used in another moment. After importing the mosaic, creating the shapefile, we can now switch to index tab to compute vegetation index. There are several vegetation index that you can use in plimanshiny. You can set for RGB and multi-spectral indexes in this case, because we have the hedge edge, the near, and RGB bands, right? And you'll be able to select in this list NDVI, NDRE, and NGRDI indexes. So I will compute these 3 vegetation indexes. Just click compute indexes, and the software will compute the vegetation indexes for this region of interest. Here we can see, for example, the NDVI for these plots. In this menu, we will be able to make the extraction for the vegetation indexes. If you just need to extract the vegetation index at the plot level and compute some statistics like median, mean, or even coefficient of variation, you can select these statistics here and click analyze. Here you can see a summary for the 3 indexes we have computed, and here you can see the indexes at a plot level. For example, switching to this step, you can put in this color scale the median for the NDVI. So you can see these plots, these 4 plots here in this line have higher than these another plots. Switch to the dataset menu, and here in the input menu you will find those results. So you can navigate here, and you can now click in these 2 buttons to download an Excel or a CSV file. So download here, and now you can open the results. So this is the brief example about how to use plimanshiny for index computation and extraction. There are there are several options you can work on. For example, if you have a time series with 10, 12 flights across the crop cycle, you can find those orthomosaics here, make a time series, import the shapefile, and create a time series for the NDVI indexes that can be used, for example, to estimate plot maturity, the plant maturity data, or even plant healing data. So I hope you enjoy plimanshiny, and if you have any question, please send an email to me. Thank you for your attention. Bye bye.